So here are the answers for 2.8 A-level chemistry paper. Okay, so the first question says that the mass spec of products obtained by making dichloride, so straight away we're thinking, oh, it's got 2 chlorines, shows that the has a regular peak at 98. Okay, so that peak's kind of telling us the MR. The compound contains 2 ions with the Cl35. Okay, so we know straight away that the mass of them both is 35 as a dichloride, so we've got 2 chlorines, so we can work that out. Suggest a molecular formula and structural formula for this compound, explaining how it might have been formed. Okay, so we're looking at, it would have been free radical substitution, and it might have come from other radicals joining together in the reaction. So that's how I was thinking it had been formed. Then I did 98, which was the total MR. Take away 35, because we said there was 2 chlorides. I was left with 28. Thought, all right, so methane, okay. So I took away 1 carbon. That didn't quite work, so took away another carbon. So it's 2 carbons and 4 hydrogens. And then obviously we're trying to make dichloromethane, but we ended up making 2 dichloroethane. Okay, and they're suggesting why did that happen? It's different free radicals joining together. Use infrared spectrometry in the given data sheet to explain how you would know a sample of 1-bromo-2 ethene contains unreacted but2N1-ol. Okay, if you had that, there would be a peak between 3000 and 3050, okay, which would show the OH bond, okay, this bond here. You wouldn't have that in this molecule here, so you'd only see that peak if it contained unreactive molecules, okay. You should see a peak here for the BR, which you wouldn't see at the beginning, but you should see as you go on, because it's formed. Using the data sheet, state how the spectrum confirms that the functional group present is propan 1-ol. You look in there, you've got that broad spectrum peak at about 3,500, and that shows the OH functional group. Okay, that's quite a common question to come up, this OH hydroxy functional group. Then it says propan 1-ol can be completely oxidized to form compound B. Completely oxidized now, not partial oxidation. Name compound B and its state how you'd expect its infrared spectrum to differ from propan 1-ol. Propanoic acid, you'd have a peak at between 1,600 and 1,700 for the C double bond O, which wouldn't be present in the alcohol. So next question then, as you can see, these are all just questions kind of going through how we use our 2 types of spectroscopy. A sample of 1,1,1-trichloroethane is reacted with excess sodium hydroxide and then acidified. One of the organic products of this reaction is liquid R, whose mass is MZ60. So we know straight away that it's got a molecular mass of 60. Okay, it then shows 2 peaks on different places. Use the information to show your workings and to suggest a structural formula for liquid R. Okay, so we're looking here to have formed either an alcohol or a carboxylic acid. That's where we're going here. Okay, so we know the MR is that. It's given us peaks there and there, so that's what them 2 peaks represent. So then we know it's a carboxylic acid or some form of carboxylic acid. So we can work out the MRs of them. Take it away and we're left with 15. So then I thought, lovely, that's going to be a methyl group. Okay. Warming 1-chloropentane with aqueous sodium hydroxide produces pent 1-ol. Use the infrared absorption frequencies given in the data sheet to explain how you'd expect the spectrometries to react differently if it was all converted. Okay, so if it was 1-chloropentane, you should see a peak here. However, when it converts to pentanol with the OH, so that's the functional group there, OH, this is the functional group here, you would then see a peak at 2,500 to 3,550. Okay, I don't know why I keep writing centimetres cubed. It's not centimetres cubed, guys. It's centimetres to the -1. State which of the following correctly decides any changes in absorption at 2,940 if the concentration of alcohol in the breath increases. Okay, so you'd see an intensity of the absorption, so you'd have to see a larger peak appearing on your peak spectrometry. Okay, false breathalyzer test reading can be given by a person who exhales Propanol as a result of illness. Okay, so propanone is a ketone that is sometimes formed. So sometimes we can't always use a breathalyzer because other things happen when using the breathalyzer. Okay, identify using the data sheet what the absorption frequency would be. So you'd have an absorption at this point for the C double bond O, which you wouldn't see if it was an alcohol. Okay, so a hydrocarbon, something that contains just hydrogen and carbon, has 85.7% of carbon. So then you can work out how much hydrogen you've got, divide it by the molecular mass or the mass number, then divide by the smallest, and then that gives you an empirical formula. So empirical formula is the smallest ratio. Okay, with that question then, it went on to say use the empirical formula, so that was what we did on the previous page, and the mass spec. So when we're doing the mass spec, we're looking for the peak at the end. Okay, so the peak at the end is 42. I worked out the MR of my empirical formula, divided them, so it would be times by 3, so then I times my empirical formula by 3. Suggest what information in the presence of the MZ15. So whenever you see an MZ15, that should be representing a CH3 group. So with that, you can kind of work out the different masses of the different parts of the compound. Final value, this one at the end, is always the total MR of the compound. So that can help you out. And then final question, I believe. Okay, state the functional group that is shown to be present in ethanol from the absorption by here. Okay, so the OH group. You get that. You don't need to learn it. It's all on a sheet you get given. Students suggested that the absorption should be used to test for the presence of ethanol on the breast. Give a reason why it's not always valid. Okay, OH bond is also present in water, so we often use the CH bond instead. Okay, if ethanol in drinks such as wine is left open, exposed to the air, it becomes sour and tastes pleasant. This is because it forms ethanoic acid. It's been oxidized. Okay, so it says draw the displayed form of ethanoic acid. So 2 carbons, oic acid is the Cu group. Okay, what significant change would be noticed on an IR spectrum compared to ethanol? So you'd have this C double bond O group, so a peak at 1650. Both would though still have the OH group around there because they both got an OH group or a hydroxy group. That's called a hydroxy group. Okay. Use infrared absorption frequencies given in the data sheet to explain how you would know if one chlorobutane is converted to butanol. So originally you'd have the Cl bond at about 650 to 800 would be replaced with a peak at between here 2,500 to 3,500 would appear instead.